this will become my P naught. Actually, this is not the P naught, because so far I trained 900 people only. So your batch, next batch are going to come again, right? This batch, next batch, again there should be get added. So this is not the P naught, this is the P value. But I'm having this data only. I treat this P naught as a P. What is a P? Sample data. What is a P naught? Population. But I have the entire population of the people who I'm going to train, and I trained. I don't have it. So far, whatever I trained only, I got this. So I don't have exposure to my population. But I have only this 900 people data. This will become my P. So I'm treating that as a P naught. I don't have a choice. You guys are understanding? Okay. In this case, this P will become, P naught will become 0.4. So now let us, so that will become the probability. This 0 into and not getting. How much is that? Agreed? So how much is this? What is the meaning of this? You guys need to understand this part. What is the meaning of this? This is nothing but the average only. How this is an average? I added all the numerator values divided by 900. Sum of all the observation divided by numerator is nothing but what? EFX only. I mean, EFX is nothing but the average, right? So P naught is nothing but what? Average, in a sense. So what is the meaning of this? Tomorrow someone wants to join the organization, I mean coaching. So if he asks me, what is the chance that I'm going to get a job? What is my answer is going to be? 42%. You guys understood this? Even anybody comes, that's what I say. This is going to change person to person. Of course, if I understand that person is an intellectual and is having a, degree in the data science, still he wants to join. He's good at academics. All those things provided, maybe he is having more chance compared to others. But on an average, what is happening? I should not answer to a person who came for the counseling only by keeping intellectual people in my mind, right? On an average, what is happening, I need to answer. If this is clear, guys, this is very, very important idea. You need to carry in the next session, after next session, again, we are going to use this idea. So someone comes, anybody comes, what is my answer is going to be? 42%. If this point is got into your head properly, so 42% is nothing but the P naught. So let's say tomorrow x1 is a random variable, which is a Bernoulli random variable. What is the meaning of the Bernoulli? This x1 may take 0 or 1. Bernoulli means what? It will take the values 0 and 1. Now this person came, I'm asking you, what is the chance that that person is going to get the job? What is the thing I am going to answer? So again, this person average also? Yes or no? That's what I am going to answer. You guys understood? Anybody comes, I am going to answer only the 42%. I am not going to change it. Even let us take, I gave this example multiple times. Someone is visiting, reaching to the office 8:30, most of the times. Sometimes 8 o'clock, sometimes 9 o'clock and all. What is it? Your answer is going to be, someone asks at what time he is going to come. Most of the times what happened? Most of the times is nothing but the average. You are going to answer 8:30 or 8 o'clock or 9 o'clock. You guys are understanding what I'm saying? So always our answers are going to be what happened on an average. So here, this P naught also kind of average? Not kind of, it is an average. But it is coming in the decimals. You guys understood this point, guys, online? So in the Bernoulli, in the Bernoulli, this is what it is. But let us consider binomial. What is the binomial random variable by definition? It is the sum of Bernoulli's. Let's say I'm having 20 people. in a batch. So each one getting a job is how much? 0.42. You guys are clear? Okay. Let us, this X is a Bernoulli. So X is nothing but what? Sum of all the Bernoullis, which is nothing but the total number of successes, right? Which is nothing but total number of successes. You guys need to have this understanding very, very clearly. Otherwise, you are going to face a lot of problems. That's the reason I am spending a lot of time on this. This is not only applicable for binomial. We are going to learn whatever the concepts in the future. This is going to hold good. That's why I'm spending a lot of time. In the future, it will become easy for me. Okay. Now, X is nothing but what? If there are, let's say, now I'm going to train 20 people. Okay. Let's say in this class, around 70 people in the batch. 70 people I am training. So how many people are going to get the job means what? It is the sum of each person. So person 1, person 2, each one is going to take what values? 0 or 1 here. X1, X2 are 0 or 1. And like this up to X70. Yes or no? Yes or no, guys? Now I want to find out the average, how many people are going to get. This average, not only for this batch, for anything, 70 people. But I'm taking the 70, what is the average? Future batch also, after DS20 also, DS21 also, if I train 70 people, what is going to happen? This what should happen? This is equivalent, I can apply E on both sides. But we learned as a formula, E of X plus Y equal to how much? EX plus EY. E of X plus Y equal to, so I can multiply this E inside. So this will become now you tell me what is this value? It's a Bernoulli, each one is a Bernoulli. How much is this value? Huh? 0.42. So in our case, that is nothing but P naught. How much is this value? You are going to answer differently to this person. Guys, you guys got this point? Online. So this is the P naught. 20 P naughts, right? Please respond. Is this point is clear to you guys or not? I think internet instability or guys or any issue. I'm going to say each individual. Here, how many these P naughts are there? If there are 10 people, what is this E of X is going to be? Hear me out. What are you saying? Since X1 can be 0 or 1, am I correct in saying this? Yes, correct. But I define X equal to 1 as a P naught. This, why I'm adding the P naught, the chance of getting this success is the P naught. So this will become N P naught. Is there any question on this for Bernoulli? Bernoulli. The average is N P naught. If I'm training people in the previous success, on an average, how many are going to get the job? how many people? N P naught. That is nothing but 70 into 0.42. It's coming around how much? 70 into 0.1 plus x2 plus up to xn, right? I'm writing in general. What is the V of x for Bernoulli? V of x for Bernoulli? What is the V of x? This is P naught Q naught. Agree? Yes or no, guys? P naught Q naught. Already we learned also. I need to add this how many times? When I'm finding out the V of x, what is V of agree? What is the each one is a Bernoulli again. How much this is going to be? How much this is going to be? Yes or no? How many such things are there? N things are there. I need to multiply n. Any question on this? I have not done anything, just applied the same thing. You guys got this logic? Okay. So now to calculate this E of x or V of x, what are the things I need to know? I need to know n. I need to know P naught. If I know the P naught, automatically I can calculate the Q naught. Why? Q naught equal to 1 minus P naught. So x follows Bernoulli, sorry, binomial with how many? You guys need to remember this. 2 parameters. If I know the 2 parameters, I can talk whatever you want. You guys are clear on this part? Friends, no confusion? Is there any confusion? Is there any confusion? I'm okay to spend some more time. Don't worry. I'm okay to spend some more time on this. Can you explain the last line? This one? Okay. V of x or E of x, whatever the things. What are the things I need to know? This average is going to change based on N and P or not only. Right? So that's the reason. It depends. This, if I can calculate whatever you want. In the formula, let us look at. I think I am deleting the old thing so that unnecessarily you can derive like this, but you can do the derivation multiple ways. Let me write it. What is the expression for x equal to r? What is the binomial distribution? NCR p to the power of r or p naught, right? Strictly 1 minus p naught. This is a formula, and we derived also with some intuition I provided how we got this. If I want to calculate this probability, what are the things I need to? What are the things actually I need to know? N, P naught. What about the R? If I know N, automatically I know what are my R values it is going to take. It is going to take between 0 to N. Yes or no, guys? What is the meaning of these parameters? If I know these 2 parameters, I can characterize by binomial distribution, right? What is the meaning of the knowing the parameters? I gave one example. Let me give one more time so that it will sit in your brain. Okay? If I go to a hospital, I want to understand my health condition. Okay? Let's say my health is gone by 2 things, BP and sugar. Okay? If the doctor knows these 2 things, he can talk about my health. If he doesn't know one of these, he cannot talk about it. Similarly, here, if I know n and p naught, I can talk about it by x. If I don't know one of these, I cannot talk about. So in case of the health thing, the BP and sugar are the parameters. If you know the parameters, you can talk about that distribution. M&D. You guys are understanding? So in this case, binomial, n and p naught are the parameters. So our entire struggle is to understand this n and p naught only. If you know what is my random variable distribution is going to be, if you know the parameters, you know everything. The data science, what you need to understand is, our job is to understand what is my random variable, what distribution it is going to follow. If only x is going to take 0 and 1, Bernoulli. If I am talking about the sum of all the Bernoullis, binomial. You guys understand? So if I know what is the nature of a Bernoulli, what is the nature of my random variable and its parameters, nature means what? Is it a Bernoulli or is it a binomial? It is something else. If I know and its corresponding parameters, I can talk about it confidently. You guys are understanding? In the binomial case, n and p naught are my parameters. Okay. Let me highlight one more point. Sarupa pointed out the right thing, but I am going to come to that afterwards. Just wait. I'm going to talk about that afterwards. Okay. So what are the things we'll learn in the binomial case? In summary, x follows binomial with what parameters? I think this is okay. Is this fine, guys? Is this fine? Okay. Clear, everyone? Now, what is the mass function for Bernoulli? P of x equal to P of x. Agree? So in the case of, it is only single trial, n equal to 1. I think I should write P naught. N equal to 1, only one trial, no? Yes, sir. Only one person, that's all. And what is the P is anyway P naught. So let us use this. How I got this formula? Let us use this n equal to 1 CR. There is how I got x equal to R. This is the formula for binomial. Okay. Now, in case of the Bernoulli, what R is going to take? Either 0 or 1. Let us keep it 0. Or let us keep it R as it is. But what is this n is going to be? 1 CR. What are the R values are going to be? 0 or 1? What is the 1C0 formula? Factorial 1 divided by factorial n minus R. That is this. And factorial 0. How much is this? Again 1. Again 1C1. How much is this? Factorial 1. Factorial 1 minus 1. And 1. Again G1. Yes or no? So 1C0, 1C1, you guys are understanding? R is going to take 0 or 1. When I'm expanding this, this is one minus R, M and D. So this is anyway, it is how much? 1 into P naught to the power of R 1 minus P naught to the power of 1 minus R. Is it both are same or not? If the X is going to, R is going to take 0 or 1. Similarly, X is also going to take 0 and 1. Both are same. So it is Bernoulli, the special case of what? Binomial. So what is that? Can I write like this? Binomial is n comma p naught, and Bernoulli is 1 comma p naught. But anyway, this one is a known thing. That's the reason we don't write like this. We write p naught only. How that formula derived? Friends, all are with me. Things are clear or not? Things are clear? Any challenge? I'm okay to repeat. I'm okay to repeat. So why the formula for Bernoulli became like this? I hope you guys are clear now. Okay. Now, let us do some problems. Then again, I'll come back to the theory. Is this fine? There's too much of theory also problem. Example. We have done the HR problem? HR problem. Okay. Data labs problem? We have done. Let's solve some KCR problem. What is a KCR problem? Let us see. Telangana government. He adopted one so on their own. They might have put already. So after putting the board, they realize that the water is not coming. So what does it mean? They wasted a lot of money. They find the water whenever they put the board, that's fine. If they are not finding the water, it's a problem. They are wasting the money. Let's say every person in the village might have tried, let's assume. So far in that village, they tried 900 boards. Already we have done the calculation. Nah? Okay. How many boards they have done? 900 boards. In that, only 386 boards only 180 boards are successful. How many boards? What is the percentage of the successful boards? X is okay. Now the question. So they went to KCR. I mean the Telangana chief minister is the KCR or other people, other state people, and requested that, sir, we are facing a lot of problem, water problem, because even we tried, we are not getting it. Okay. Now KCR promised that I'll put up one big board and I'll establish one tank. What is that? I'll construct one tank and I'll put one big board and we'll dump the water from this big board to, I mean water to that tank. So whenever you guys want, you can use it. Is this fine? So now the question is, what is the budget? KCR has to allocate to put the assume each board cost equal to, let's say, 1 lakh. Each board cost is how much? 1 lakh rupees. So as a KCR, when he wants to put how many bores? How many bores? Only one bore. Okay, he wants to put it. So whenever he put the bore, he is going to get the water. Huh? He may get, he may not get. So let's say after one attempt, he may get the water if he is lucky. After two attempts, he may get the third attempt, he may get it. Means what? Third attempt means what? First two attempts, he did not get the water. You guys are understanding? Maybe sometimes, if he is unfortunate, maybe 5 bores. After 4 bores, 5th bore only got the success. So once he gets the success, he is going to stop it, right? You guys are clear or not? Friends, all are with me? All are with me what I said? When he is going to stop? When he is going to stop? Once he gets the water, he is going to stop. So this problem, now the question is, what is the budget he has to allocate? He doesn't know how many bores he has to put in. You guys understood this? It's a typical practical problem or not? What is the P naught here? Let us use this Excel to solve it. What is the P naught? 0.2. What is the P naught? What is the 0.2? How I got this 0.2? Successful bores 0.2. Please be clear. What is the 0.2? Is it a successful bores or failure bores? Successful. So here, whatever the n, whatever these values are successful bores, how many bores I need it? How many bores I need it? Only one bore? KCR require one bore? So to put one successful bore, how many bores he has to do? All are with me? To reach this one success, he might have failed in the previous attempts. Few bores, how many such bores? Okay, sir, clear or not? So what is my interest? I want only one success, right? I don't want any other. Do I need 2 successful bores? No, no, no. As per this problem, only one success. After that, I am going to stop it. So to keep one success, what is the minimum number of bores I need to put in? If I put 100 bores, definitely at least one bore is going to be successful. That is the attempt he is going to make. He is going to allocate for 100 bores. You guys are understanding or not? So how many minimum number of bores he has to plan? I mean, he has to budget so that he'll get the at least one successful bore. At least. Yes or no? What I am interested in? This should be around, let's say, 0.9 or 0.95. So what is the meaning of this 0.95? I am 95% confident that if you put these many number of bores, I am going to get at least one bore, successful bore. That's what is the meaning of this. Let me repeat one more time. Let's say I am saying this. I'm going to the what if analysis or 95%. Okay, you can be 100%. Why not 100%? We'll talk about this. Why not 100%? Why only we are looking at the 90, 95? We'll talk in the future. But for the time being, take it my word as it is. Is that is okay? So this I'm saying as hope Excel is going to give the answer by changing what? This one only. So this is going to give how many such bores I need to keep so that I'll get the at least one successful bore. That's what I'm trying to run. Oh my God. How much is that? Around 11 bores I need to prepare. If I prepare for 11 bores, at least one successful bore I am going to get it. How much of money I need to allocate? 11 lakhs? You guys are clear on this? You guys are clear on this, friends? Is it not the same thing like recruitment of a CEO? You need only one CEO, right? How many so that I get at least one CEO? See, case to case things are going to change. The calculations are going to go to the same manner. So you need to have the ability to think how you need to fit this mathematical to your problem. Make sense or not? Make sense or not, guys? Okay, let me repeat whatever I said. Yeah, I'm having an internet problem today. I don't know. I'll fix it. So, too much of rain are happening now. Okay. Shall I repeat this? What I'm saying is, Pravina, shall I repeat or? Okay, let me repeat one more time. What I'm saying is, I want one successful board. For that successful board, how many boards I need to put in? But past success rate is only the 20%, not more than that. Only 20% of the people got 20% of the boards are successful. One person might have tried 2 times, or 3 times. If he is rich, he might have tried 5 times. Okay. So what I'm saying is, how many successful boards were there? Only 20%. Now the question is, KCR promised 1 boring for that village, a big board. Okay. So now to do that, he has to allocate some budget. How much budget he has to allocate? This is going to give what I solve this. How I solve this? What is the meaning of this? When I solve this, I'm 90%. I should be 90% confident. At least I'll get 1 board if I do the 11 boards. Let me write that statement. I am 90% confident I get at least 1 board if I prepared to put 11 boards. Ravina, if this is clear now? Okay. So I gave one more example, the CEO example. What is the CEO? I want to recruit a CEO. Only 1 person only I need it. Huh? Do I need 2 CEOs? No, no. So at least 1 CEO I need to calculate. Or exactly 1 CEO, whatever it is. Okay. But we are interested in the at least 1 CEO. Because if I got the 2 CEOs, I'll pick one of those. If you have 10, if you want to have 3 good apples, what is the problem if he putting the 10 good apples there on the floor? Make sense? Okay. So I want to have 1 CEO. So to have 1 CEO, how many interviews I need to conduct? How do I know the p-value? In the past also you might have done some interviews. Based on that you take the p-value, use that p-value and do the same thing. You guys are clear now? Friends? So here in this case, what I've done, I don't know the n. I don't know the n. But I know the r value, r equal to 1. This distribution, the problem what I have done, x follows, this is called a geometric distribution. The geometric distribution, what are the parameters? I am not going into the details of this, but I solve this using the binomial itself, right? R and P where r equal to 1. What are the parameters for the geometry? I am not getting into the details of this. It is not in the syllabus also, but without having an understanding of this, what is the meaning of this? For r equal to 1 and p naught, how many? I am going to calculate the n value. So this is called geometry. But we have done that not only for r equal to 1, if I want to recruit 10 people, how many? Then I call x follows negative binomial where r and binomial, this is binomial, r and p naught are the parameters. So this geometric distribution, a special case of the negative binomial, geometric distribution is a special case of. So what we are going to calculate here? N. What we are going to calculate here? N. But in case of the binomial, what we are going to calculate? For R value, given R, what are the things? What are the different probabilities? You guys are getting clear? So geometric distribution is a special case of negative binomial. This is the first part. Similarly, Bernoulli is a special case of binomial. You guys are understanding, friends, online? Because n equal to 1, that will become the Bernoulli. So far so good. Let us solve one more problem. You guys understood? Sarupa, I think Sarupa asked a question. Did I answer your question, Sarupa? Yeah, let me repeat. What is the geometric distribution? If R equal to 1, only I am interested in only one success. After that, I am going to stop the process. For that, how many n I need it? That is the geometry. It's a reverse. What is this? Negative binomial. I am interested in the R. Let us solve one more problem. Example. Okay. I want to recruit 10 people. How many interviews I need to conduct? From the past, successful interview percentage is, let's say, 20%. What is the meaning of this? If I conducted, let's say, in the last 100 interviews, only I selected 20 people. All are with me? Let's do this. Here, same 20. Let's make it this stop 20. Let's make it 60. 60 and 70. So this is a 0.6. Do I know n value here? I don't know the n, but do I know the r value? I know r. I know the p. I don't know the n. That's where the negative binomial. Is the point is clear? But let us solve this problem again. So this one, I want how much? I hope. To a value of, let's say, 0.9. By changing what? This one? How many people I need to, how many interviews I need to conduct? Given this, yes or no? That is a success rate. How many interviews I need to conduct to get that at least 10 people? 21 interviews I need to do. So here, I don't know the n. I'm calculating the thing, right? Yes or no, guys? So this is called negative binomial. I know the n. This is some 10. And I'm calculating like this for different values. This will be the binomial. And given r and given p, if I'm able to calculate this, that is called negative by none. All are with me now? Sarupa? Everyone?
Yes, sir. Yes, sir. It's clear.
Okay. Now, shall I take another few minutes more so that we'll complete few things? Let me solve one more problem. I think let me talk some theory. After that, we'll see if time permits. Okay, let me solve one more problem. Example. It's a traffic problem. What is this traffic? Normally, in the traffic, when there is a signal, people jump the signals. Every time we are talking about the at least only, in which case we take exactly, we don't consider exactly most of the times. Okay. We don't even consider. Of course, there are a few instances you consider. There isn't the problem, you need to think which one to consider. At most, I release the product if I get only up to 2 defects. Beyond that, I am not going to release the product. At that time, at most. Yes or no? You guys are getting what I'm saying? If I get I release the product up to 2 defects. Beyond that, I am not going to release. So, past data or past, yes or no? So based on past, I'll calculate what was the successful coding. So what I'm saying is, let's say, let me, yeah. So this is a person did 900 lines of code. How many lines of code? 900 lines of code. People may not like it because 40% of the lines of code are not successful. No? Okay, that's fine, but for our consumption. Okay. So in the past, he has the project team written 900 lines of code so far. It could be 9,000 or 9 lakhs or whatever it is, but for our consumption, I've taken 9,000. So in that, how many lines of code went wrong? Here, 40% of the lines went wrong. Now 900. Tomorrow, the project he has written, let's say, some 100 lines of code. This is a failure thing I'm talking now. This one is 0.42. Yes or no? What is this 0.42? In the past, they have written the codes, and these are the number of failure codes. The P is corresponding to the failure codes. All are with me? Now, let's say he has written, he is going to write, or he has written already, let's say some 100 lines of code. Until unless I have maximum 3 defects, I'll release the product. More than that, I am not going to release the product. If I release the product, customer is going to penalize me. If that is clear? So here, this will be the 100 lines of code. So at least, what is the chance that at least you are going to find 3 defectives? 0. So I can comfortably